All right, you guys, today the notes are going to be on chapters 1.1, what is statistics? So what is it? So statistics is a study of how to collect, organize, analyze, and interpret numerical information from data. I want you to take a second, pause this video, and read pages 4 through 6. So as you read, individuals are the people or subjects included in a study, and a variable is a characteristic of the individual to be measured or observed. So individuals could be people who work at a school. A variable would be about that individual, so heights of the people who work at the school. So now we have quantitative and qualitative data. So a quantitative variable has a value or numerical measurement. A qualitative variable describes an individual by placing the individual into a category or a group. So I have my people here. So if I were to categorize these people, or not necessarily categorize, but if I were to talk about them with quantitative variables, I would say height, weight, age, or income, because these are all number values. If I have qualitative variables, these are things that I can categorize, such as gender, nationality, marital status, hair length. These aren't things necessarily that could be translated into a bunch of numbers. For example, if I'm going on gender, I have males and females. So now I have population and sample data. So in population data, the data are from every individual of interest. In sample data, the data is from only some of the individuals of interest. So a population could be all the people that work at a school. A sample of that population could be the females that work at the school. Note that a sample is not complete. It does not represent an entire population. So we have population parameters and sample statistics. A population parameter is a numerical measure that describes an aspect of a population, while a sample statistic is a numerical measure that describes an aspect of a sample. So an example of a population parameter is men who work at school. So we have the entire population. So a parameter of that population would be the men who work there. A sample statistic would be men who work at school with facial hair. So it's like a part of the parameter. So here, let's try an example. The Harris Poll did an online survey of 2,286 adults within the U.S. The survey asked if the respondents agreed or disagreed with the statement. Learning and habits from music education equip people to better team players in their careers. In the most recent survey, 71% of the study's participants agreed with this statement. So first, we're going to identify the individuals of the study and the variable. So when we're identifying the individuals, we're thinking, who are the people? Who is being studied? Well, if you read the first line, it says we have these 2,286 adults within the U.S. So those are our individuals. And then our variable, remember, is the characteristic. So what is being observed? So they're either agreeing or disagreeing with this statement. So does the data comprise a sample? If so, what is the underlying population? So remember, with samples, it's part of a population. So these 2,286 adults, they do not represent the entire population of the United States. They're just a sample. So does it comprise a sample? Yes. Is the variable quantitative or qualitative? So is it something that we can measure by numbers? Or is it something that can be categorized? So it's qualitative because the categories are the two possible responses. Next, what could be a quantitative variable that might be of interest? So if they're surveying these adults, what would make these adults respond differently? That could be a quantitative variable. So remember, that type of variable is something that you can measure like with a number. So maybe possibly we could say age or income might alter the response of their agreeing or disagreeing with this survey. Is the proportion of respondents in the sample who agree with a statement a statistic or a parameter? It's a statistic. The proportion is computed from sample data. Take a second and read through pages 7 through 10. All right, so there are 4 different types of data, or necessarily levels of measurement. So we have nominal, ordinal, interval, and ratio. Okay, so with levels of measurement, nominal applies to data that consists of names, labels, or categories. So I have my 4 people here, and if I were to say, okay, their names are Amanda, Kelly, Sarah, and Lauren, this would be at the nominal level. Now I have ordinal, applies to data that can be arranged in order. So I have listed the ages of these people here. So I have 18, 21, 23, and 24. So since they're at the ordinal level, that means that they can be like ranked, essentially. Arranged in some sort of order. Next, we have interval. Now, interval applies to data that can be arranged in order as well. Difference between data values are meaningful. So years these women started teaching. Ratio applies to data that can be arranged in order. Differences between data values and ratios of data values are meaningful. Data at the ratio level has to have a true 0. So ages of the teachers. All right, here's our second example. So we're going to identify the types of data. So Concord, Walnut Creek, and Pleasant Hill are cities surrounding Grand Isle. So notice that these are cities, and the data that we have that consists of names, labels, and categories, right? We have these three names. So this would be nominal. In a high school graduating class of 319 students, Josie ranked 25th, Joe ranked 19th, and Sally ranked 4th, where 1 is the highest rank. So now we have ranking, all right? And remember, with ranking, we're thinking order, so ordinal level. Body temperatures in degrees Celsius of trout in the Yellowstone River. Okay, so now this, we know that we can order our data and that we can also compute meaningful differences. In this specific case, we are using the Celsius scale, and that there's no inherent starting point because the value 0 degrees Celsius doesn't indicate a value of no heat. All right. So for this one, it would be interval. Now we have the length of trout swimming in the Yellowstone River. So if we're talking about this length of trout, this data is going to be at ratio. Because we could say an 18-inch trout is 3 times as long as a 6-inch trout. All right, and we can divide 6 into 18 to determine the meaningful ratio of trout lengths. All right, you guys. Thank you for bearing with me for this first slideshow. Please excuse all of my typos. And your classwork is due the 21st, page 10, numbers 1 through 4, and 5 through 15 odd.